Hey guys, welcome! Today is another update day video of the Bridge Optimizer. So, let's jump into it. Without further ado, we are looking at what changed. It's quite a bit. So, in the last video I was considered with driving lane logic, and now it's time for taking the results. Yeah, and a little bit more than that. So first, what I did first here was creating a method for screenshots. So when you have your bridge design proposal from the optimization, you would, if you're doing that in batch, you would have it rather screenshotted in a folder that you can quickly look at it. You don't need to open a hypermesh file in that case. So this would be a thing. Then I have also the removal of rods which are low density, so you could set a density threshold and all the rods which show a density value lower than that will get removed. And then we have a bridge visualizer, because I wanted to see what rod removal would look like. So I implemented a bridge visualizer which just makes lines wherever a rod is. And then the problem came up with that rods are put onto each other, pointing in the same direction, but are not one rod, but multiple rods. Because, for example, if you have your grid space like this, that for each node you just link the node to the next node in all directions, longer rods are just possible with a multitude of, grid length long rods. And because you maybe want to combine them, I have a implementation of this combination method, which looks at if rods are pointing in the same direction and the node in between is not connected to any other rod, and then this is getting combined. And finally, I did some documentation and also the implementation of a meta class, meta class, which covers the following. You want to have multiple studies in an easy manner. So finally, first you just define what you want to study, and then it gets run every iteration, or every study, you could say. So we will go chronically through there, and I will point how I did that. Maybe I will do a little bit more detail on the hyperview scripting thing, because some pointed out to me that this is something you guys would like. So I will maybe do a separate video on how I code for hyperview, but this is just a basic update video, so I will go over that in a more brief manner. Alright, let's jump into it. It's easy for me now because all the things I added in the main class are at the bottom. So you have here the density file. So this is the first thing. Actually, it's the second in implementation, but it's the first thing here. So this is removing all the rods which have a density less than a threshold. And you have this in the method of the instance of the class bridge. So this method, remove rods with low density, takes into account the simulation directory. So there's all the simulation data, then the path to the des file, which is the result file with _des. There's the density in there. So this is a hypermesh output file, a H3D file. And then you have the path to density file. This is the output. So there will, on this path, all the densities for each element will get stored, and additionally node information, and I think component ID also, and your density threshold. So this is the input for this, and let's briefly strive through that method. So you have your calc there, and you have a script builder, which is also new, script builder hyperview. This has different methods, and one is write density file, which is exactly the one which is getting executed here, somewhere, here, write density file. And in this, the commands will get put together and hyperview is called. And here there is a command which says write data output path. And this output path is specified up here. And this is the path to the density file. Out. called it out, that I know that is an output. It's a little bit documented. Maybe not so good as it should be, but I think if you look into the code, you'll manage to be able to follow through. So this puts the script together, this method here. Then it starts the hyperview starter, Hyperworks starter. I renamed that. That was the hypermesh starter initially, but now has also run hyperview, a different command. This run hyperview runs in contrast to the run hypermesh, which runs the HM OpenGL. No, HM batch. Yeah, the HM batch or HM OpenGL, depends on whether you want to run it in batch or not. This will run the HW exe. This is the path hyperview, which is also covered up here. So path hyperview is Altair home. So this is the standard HW exe. And where is my run hyperview? Here. So if it's in batch, a B is added to indicate that. And if not, just TCL and then the TCL file. You know that from the hypermesh start. It's the same logic. So this will getting run here. This is run here. Run hyperview, and you have true for batch and true for wait. So this will wait until this is done, because then you have your file and you go through the file and read the density value, and if you have a density value less than the threshold, you remove the rods by firstly adding all the rods to remove to a list and then removing all those rods from self.rods, so from bridge.rods. Because bridge.rods, this is the collector with all the rods which are belonging to the bridge. Yeah. Alright, so this is that. And yeah, so remove rods with low density. This is the first thing here. Alright, screenshotting. Same thing. But different script file. So you have your hyperview script builder. Once again, I could use the same, but I didn't think I should. Well, okay. So you have your script builder, hyperview again, and then screenshot element density. This is the method here. And this takes into account, again, path to the des file and the density threshold. And this puts some other commands together. And you see here the screenshots, for example, here. Actually, there are two. So this is the second one. I think here the rods are not displayed, which show a density value of less than the threshold. But you have a first screenshot with all... God, you had... Here. First screenshot with full elements, yeah, so with all the elements. We will see or look at that in a minute. Alright, so this is script screenshotting. Yeah, you have the TCL file, which is built here. Then you have your write script, which puts out the TCL script, and then run hyperview again, like up here. It's the same command, and also will wait. Now here comes the more difficult part. Combine rods where possible. So it's a method of the bridge, and it takes on the grid because it just has to get the coordinates. Yeah, why is that? We will see. And this is rods pointing in the same direction with no additional rods connected in between will get connected. We will see how this looks like. Well, this method maybe could for sure be programmed in a more clean and straightforward way, but this works. It's also, I have to say, it's also recursive. There is a measurement here, length before, so the number of rods before the combining action, and also the length of rods, so the number of rods after combination. And if that's different, the combine rods will get executed one more time. Because I had the problem, I'm not really sure where the problem is, but I had a problem that it is combining one step but not two steps, or some rods should be combined but aren't. In some models it worked on the first try, but in others it didn't. And why is that? I should research and try to come up with a more error-prone, error-safe logic here, but with the recursive it tends to work. So I will not go into the details. I think this will just bore you, but it will combine the rods which are possible to combine, and we will look at that in a minute, how this is playing out. I think right now, right? Because we have a bridge visualizer here, and this will just put out the rods with lines, but there you can also see the connections. And yeah, last thing, so we covered it now. We covered all the pull requests up to here. The meta class is still lacking, so this I will just cover because it's not that big of a thing. But you know, last time the class bridge optimizer, this was the main, and it was just executed once. But now I want to have it be able to be executed 1, 2, 3 many times, right? And because I want to change some parameters, and the way I'm doing that is by giving a parameter values, which is a dictionary, which has keys and values stored. And you see that variable used quite often here. So length is now the variable stored in the key length of the dictionary values, and not a fixed value anymore. So the main method down here consists like the following. So you construct your dictionary values. You say for your simulation directory, you, for example, want to have study test in ctemp. Then you want to clear it, and if it's not existent, you want to create it. So this is all that part. And then you have some values. So the spacing should be this. The neighbor distance threshold should be this. And here's your first bridge optimizer. This is a first study, a first modeler, first optimization. And then you change some values and you run it once again. You may ask why the values seem so incomplete, right? There's much more values than just those 3. And that's because I have another method which is called load default values, which loads a dictionary into the variable default values. Sorry, that was a misclick. Here. And here all the other parameters are loaded, which are the default ones. And now, the thing is that I'm going through each key in the default values list, and if that key is not present in the values list, which is giving or handed over as a parameter, I just replace nor. I insert the key and value into the values, which is not there but should be there, and I'm inserting the thing from the default values. So that's easy enough. And then for the folders to be unique for each study, I want to have a different folder, and for sure I use a datetime operation, which is not really sophisticated. I should improve that, but it works for now. So your datetime object gets the timestamp of now, and you just include that into your folder. So this will be taken here. All right, let's see. I want to go to ctemp to just show you how the structure looks like before executing something here. So here's my ctemp, and I will just delete everything here. And then it will not work because the folder is missing. I don't know, just kidding. So empty folder here. And now the first thing what we want to do is we will just comment out those 2 lines and just make one simple bridge. This is more or less the default values, right? Yeah. So this will be taking a bit. And yeah, what else do we want? Maybe we want to not combine the rods for right now and visualize it. So the bridge visualizer, I did not talk a lot about it. So this just builds a script with different TCL commands. It creates the nodes, it creates the rods as lines, and this is just this little bit of code. It's not that interesting, and it just executes it. So this is everything. Yeah, so we are running now a standard simulation or optimization with no combination of the rods, with screenshots, with the visualizer at the end. So, and now my typing skills again. Ignore that duplicate ID. I should research them what this is causing. I changed the way the blackout zone works, and I think it has the problem that 0 is considered to be a duplicate ID. I don't know really, but it didn't seem to have caused a problem until now. But yeah, the thing to make an issue on. So you see now it's running everything in batch, so we don't see much. And by the way, I'm not expecting any license errors, not whatsoever, because I borrowed all the licenses I need here for this simulation. And if you want to check out how I did that, I think I put up a separate video for that. It's just a quick tip video, because the HWU, so the Hyperworks units which are hosted, they can be borrowed max 24 hours. So this is the thing. Right now the bridge optimizer is starting. So it's not sized here correctly. Just wait a second. And by the way, the visualizer will also delete the temp nodes at the end. So this disappearance here is normal. So this is what I'm getting. And here you can see, if I put the selector to lines, you see that I have all those separate rods together. And here's the driving lane, which has the bigger rods. And here's all those simple rods. So if I switch on those the combination here, I'm expecting to see that those rods will get combined. And this is what we will be just looking for now. So I'm turning now the bridge combine rods on and run it just once again. And by the way, we can look at here. So this will be emptied, or was emptied just a few seconds before. But now you can see this is the first iteration, first model of the displacement where you're just getting the displacement value of the full design space. Now the optimization is running. And I definitely have to write a cleanup routine for that, because all those error messages and whatever could be deleted automatically if I'm doing a bigger study. The cleanup process should delete all the not wanted files after a successful run, because you don't want to waste disk space. Now this is the visualizer, and this is maybe taking the most part of all, because it has to load up Hypermesh or Hyperworks. And this is the thing about batch. Batch is really cool. Right, you can see rods are combined, right? And so first time ever, I'm thinking we have something more complete. That's for sure. There's 102 things to do here, but I think it's quite good. The first good step. All right, and now comes the cool part. Let's skip all the visualizer and just make multiple optimizations like this. And maybe I will, yeah, I think that's okay. It's 2.5. Then it will not take that long. But you could change everything here, right? So maybe change the length as well. I'm feeling lucky again. Values. Length. Normally is 32. Let's make it 7. Something. Which is not an even number. Let's see if that works. Alright, I got it. Yeah, it was the mistake that rod.instances, which is a collection of instances of the rod class, is initialized at compilation time only and is not resetted. So rod.instances equals an empty list is introduced in the main script to get rid of that. So that means every time you do a new study, before creating the rods, the instances get cleared. And this is what makes me able to do this. By the way, I also fixed that duplicate ID error, ignoring all zeros. This is another thing I did. So, and while this is doing, I can just quickly get rid of the grid printout here, because I was using that for debugging issues. So you see all the IDs, and the thing how I got to that was that it requested a ID which is not available, and the ID was much higher than the ones in here, and so I figured out it must have been the rod class, because the rod class chooses the IDs based on the length, I think. But yeah, this was basically it. So this is doing its job here. So I'm not so happy about this. I don't know if that's okay, but we will see. For right now, it seems to work. And you can see here in the ztemp, you have the 2 folders. So this is the initial folder, which you saw already. So this. And now the second folder, hopefully, will be here in a minute, right? So here you see different length. And, oh, okay, interesting. So here, and maybe that's the reason why the optimization entered with that strange exit code. Let's quickly look into the optimization out file. The model name optimization. Error. In static load case 1, the compliance is negative or large. Optimization buckling analysis cannot be performed. Infeasible design. Can we figure out why? I think. Well, you see, there's no thing like this. So this seems for me to be the thing. After all, it still is about this thing. Some of the if conditions. This link's already drawn. Ha! Here it is. Oh god. Alright, so this link's already drawn. Should not be a class variable, I think. Because let's take that here for a minute and put it right here. So this should be good. There are another links already drawn? Because it should be used just here, right? Yeah. So I think that this will be only occurring if we do 2 optimizations. So we have to make both optimizations once again. Because I think it's the same thing again with the class variables, and that teaches me and you maybe a valuable lesson. You see, the class variables, they can be a pain in the back when doing multiple instances or multiple runs of the main class, because the initialization doesn't happen again. So all could argue for all of those, for the dictionaries and something like that. But dictionary is another thing, because if you put another key into that, it will be overwritten. But all those lists, whenever you have a method like here with create rods, something which populates a certain list, for example, then it would be obvious, would be wise to just clear or empty that on those methods and not so much in the class variables. And I think with that principle in mind, I will have to look through the code if there's additional stuff like that, because, well, there's a lot of possible classes where we have something like this, right? But here we have self.rods equals rods, so here it's getting replaced, so that's okay. Grid also, and the costs, well, the costs, I think those will be set directly as well, right? Okay, so I didn't look now in the console, but we will see in a minute here the second optimization. Yeah, looks a lot better, right? Or does it? Well, actually, it seems to fail as well here, but I don't know why, because now it seems to be connected. That's okay, that's good. And I think now it would be time to look into the finite element model. So we have the FEM file here, and I will just directly import that. See if it, yeah, it tells you the exit code. If that's not 0, something went wrong. And I'm sure it's the compliance thing again, which could mean two things. Or maybe just one thing. I think it's about boundary conditions. Oh. Interesting. So we have a load step here, which belongs to the other model. And the second one is the correct one. So another one of those class issues when doing multiple runs. My god. So we have a script builder boundary conditions. And here a TCL command list is given. And here you have load collector.instances. Which is fine. But you see here another one of those instances. So I should take care of that in the main class. So we have load collector. Well, load collector dot instances equals empty list. So this is taken care of. But we have another thing like force. A separate section here. No, that's not happening, right? Force has no instances. Good. Load step does have instances. So load step instances equals. And just to be sure, I search for files and search for instances. So that's okay. Load collector we have taken care of. Load step also. Model entity. Phew. Rods we have taken care of. I think it's just that. Hmm. So for each property, well, material doesn't have instances, but property has. And component has too. So, for this, I think this is in the model entities. Take it. There's property.instances. Or rather, here. Alright. Last shot? I think so. Hopefully this works now. But you see, I wasn't assuming that this would happen, and we have such a nice, longer debugging session. But yeah, I hope that it also was valuable to you to see what could go wrong and learn this lesson of how to identify where this particular thing is happening and to correct it in the code, and also the reasoning behind it. Yeah, because the thing was, I was so happy yesterday as I made this progress, because it worked for one iteration and the second also, which didn't change the length, because length changes everything. So it changes where the boundary conditions are, and therefore we have the whole hiccup with the load collectors and load step, because if the thing doesn't change, you maybe have 2 load steps. Who cares, right? Works either way. But as soon as you're changing the length, it works. And I changed the length individually once. This worked too. So I didn't think that this would happen. But yeah, you see also here, and I say that maybe too often for me to not consider implementing proper testing, but proper testing is so damn important. And I really should make that a little bit of more priority. So hopefully this works now. Yeah, a bridge is built. That's a nice one. Why is just alright, yeah, here you can see the effect of the driving lane. You cannot see it directly here, but I'm assuming that this is it. You have a starting point here, and the max beam length was 8. So the first element was put in the driving lane up to here. And as you have just loads on the driving lane nodes in between, this will get this asymmetric design. But I like it. Find it quite beautiful, and maybe this one can get rid of. Lighter colors. And that it has this bending here, this change in direction here a little bit. I don't know. Doesn't make much sense. A straight line, I would prefer the straight line, but I think the solver didn't have a straight line for available, right? So there's no straight line from here to here. This would be 1, 2, 3, 4.5 times. 4.5 times the spacing required that it has this element as well, and then it will get used for sure. Alright, I think this video is now long enough. I will wrap it up. So thanks again for watching. I hope you learned something, and I learned something for sure in this making this video and uncovering all the things which did not work until now. The proper need of tests. So this is a thing I am ignoring for much too long. But yeah, I think for a fun project it's okay. And also, but as soon as you get a certain complexity level, you see that tests is not an option. Tests are required. And I will make that in the future. So for sure I will be making tests here. and implementing them. For now, the most bothering thing for me seems to be that I have no summary file of all the optimization runs and no error handling. So I think first two things I want to take care of is error handling, so make sure that the optimization runs through no matter what. If it fails, the next run should be just started and a message should appear. And the second thing which bothers me too is getting a summary of all the studies I was doing in particular. And I'm thinking about a markdown file which just combines screenshots and valuable data of the optimization models. So I'm thinking about, for example, the compliance as a metric, the mass as a metric, so for sure because it's the optimization variable, the costs as a metric, although I know the costs are not properly implemented and there's a lot to think about, because for right now the combining method, you see this longer rods. Yeah, well, what do you do with your max beam length constraint, max rod length? This is not taken into account. Maybe this should be, but that brings another question, because why in the hell is it working when you have bearings between the rods? And this leads me to that we have a modeling flaw. We are not modeling what the game is modeling, because in the game the connection between two rods is moment-wise completely free. So this now starts the thought, well, maybe you should make the rods independent and then just combine them with couplings where you transfer translational force and displacements, but nothing with rotation. And yeah, you can see there's a lot of things to do. Then again, rods cannot transfer bending moments. But I think it's just this, that those are free in rotation, but as you rotate downward, both of them will get longer, and because they're getting longer, stiffness is reduced. And this is the thing which happens here. But I should make a short test model to just validate that. But yeah, for now I think that's enough for an outlook. I hope you had fun watching this, learned a thing, and if you were happy or have anything to comment, please feel free to do that down below. I will just look forward to hear from you, and yeah, see you around.